Now class, we're going to pick up where we left off at with D. Now if you notice here, we don't have C over here, but if you need to look at C, C is in the previous video. I had altered this slightly so I could move this D over here to give me enough room, because I'm going to show every last step and then I'm going to show you the shortcut. For this problem here, you could copy down every last step or you could do the shortcut. So I'm just going to show both versions. Okay, the first version is every last step. Now with every step here, we would take this 6a to the 5th multiplied by, this will be 1 over b to the 3rd divided by, this will be 12 times 1 over c squared. Now we want to multiply these. We'll put 1 in the denominator here, 1 in the denominator here. 6a to the 5th times 1 is 6a to the 5th. 1 times b to the 3rd is b to the 3rd. All over. 12 times 1 is 12. And 1 times c squared is c squared. Now we have 6a to the 5th all over b to the 3rd divided by 12 divided by c squared. So this is the same as, we'll keep the first factor the same, which would be 6a to the 5th over b to the 3rd. The division becomes multiplication, and we take the reciprocal of the second fraction. Now we can multiply. Now we can't do cross simplifying. We know 6 goes into 6 one time, 6 goes into 12 twice. So now we will have 1a to the 5th times c to the 2nd, which is a to the 5th, c to the 2nd. That would take care of our numerator. Now our denominator, b to the 3rd times 2, is 2b to the 3rd power. Now this problem is finished. Now this is the traditional way of doing it, where you show every last step. Now there is a shortcut version. Now like I told you before, I would specify on the test how many of these that you would need to show every last step and how many you could use the shortcut method. So we look at D again. Now what I'm going to do is I'm going to draw this arrow because I don't want to write the whole problem over again. So we're going to say that we're starting here. Now what happens is this here. Whenever you have a negative exponent in your numerator, what will happen is it will go directly to your denominator. And whenever you have a negative exponent in your denominator, it will go directly to your numerator. So this will become 6a to the 5th, c to the 2nd, all over 12b to the 3rd. Just like I told you, this exponent was negative, it goes to your denominator and becomes positive. This exponent was negative, the exponent in this base goes to your numerator and is positive. Now we simplify. We know 6 goes into 6 once, 6 goes into 12 twice. So it'll be 1 times a to the 5th times c to the 2nd, which would be a to the 5th, c to the 2nd, all over 2 times b to the 3rd, which would be 2b to the 3rd. And as you see, we have the same answer. Now I want to say this again before we go to the next problem. Remember I said I will let you know when you can use this shortcut. Until I tell you can use the shortcut, you have to use this method here. Okay, now we need to scroll down. Now we want to go through the summary properties of exponents. I took the liberty of putting them up here. The product property for exponents, remember same base, carry over the base, you add the exponents. The quotient property of exponents, you have the same base, you subtract the exponent. It's the exponent from the numerator minus the exponent from the denominator. Raising a product to a power, Now, with this here, just to let you know, if the exponent of these base are 1, then that's when you would just replace the exponent with n. We'll address if the exponent is a different number from 1 a little later. So x times y, both of them have an exponent of 1, so you will end up with x to the n times y to the n. And the same thing here, both of these have an exponent of 1, and since this whole fraction is taken to this exponent, it'll be x to the n over y to the n. Now, number 5 addresses when our exponent is not 1 on the inside of the parenthesis. Now, this m could be any number. So what we would do here is we would keep our base the same, and we will multiply our exponents. So it'll be m times n. So it'll be x to the mn. Now, we scroll down here. Now, it tells us the process for simplifying power expressions. You can read this at your leisure. And we're going to go down here and start these problems. Okay, example 4. It says simplify. We add x to the 6 to the negative 3 power. Now, you could either combine the exponents, or you can make this 1 over parenthesis x to the 6 to the 3rd power. I think I would rather combine the exponents first. It's just a personal preference. It'll be 6 times negative 3. So this would be x to the negative 18th power. And we know that equals 1 over x to the 18th power. And that is our final answer. Now, we look here at B. We're multiplying. So what we would do here, remember, the only thing that's taken to this negative exponent is this x. This negative 5 is not. So, why don't we complete what's inside the parentheses? So we have 4x to the 3rd. And in this parenthesis, we have negative 5 times 1 over x to the 6th power. Now we can multiply what's inside of that parenthesis. And we will multiply that by putting a 1 under the negative 5. So this will end up being negative 5 all over x to the 6th power. Now, we could rewrite this here and make this 4x to the 3rd over 1 times negative 5 over x to the 6th power. Positive 4 times negative 5 is negative 20. And we have our x to the 3rd. We carried it over. And our denominator, 1 times x to the 6th is x to the 6th. Now, we have a little bit of an issue here. We could still simplify these exponents. But we'll write our negative 20. Our base is x. And we'll have 3 minus 6. Now, let me draw this little arrow here because we need some more space. So we had negative 20, and then we would have x to the negative 3 power. So now we had negative 20, this x to the negative 3 power, so it'd be times 1 over x to the 3rd power. We could put a 1 under the negative 20, and our final answer would be negative 20 all over x to the 3rd power. And that is our final answer. Now we scroll down here. We have example 4. Now, what we have here is this here. What's 30 divided by 10? You're correct, it's 3. Now b to the 3rd over b to the 8th. We have our base, which is b, and then it'll be 3 minus 8. So we have 3 b to the negative 5 power, and this will become 3 times 1 over b to the 5th power. Now to finish this problem out, we'll put a 1 under the 3. 3 times 1 is 3, and 1 times b to the 5th is just b to the 5th. Now we go to D. We have 7x to the 4th over 3x to the negative 3. So we'll have 7/3 times, this would be x to the 4 minus a negative 3. Because remember, our base is x. So we have 7/3 times x to the 4 plus 3. And this will give us 7/3 x to the 7. And that is our final answer for that problem. Now we scroll down here to E. Now with E, everything inside this parenthesis is taken to this negative 3 power. So let's do it like this. We'll put this as 1 over parenthesis 3x to the negative 4 power to the 3rd power. Now, let's do what's inside of this parenthesis. We'll have 3 times 1 over x to the 4th power, all taken to the 3rd power. So this would be 1 over, we could put this 3 over 1. 3 times 1 is 3. And 1 times x to the 4th is x to the 4th. And that's all taken to the 3rd power. Now, we'll take this as it equals. We will have 1 divided by, in parentheses, we will have, let's do this, 3 to the 3rd power. Well, we'll make this 3 to the 3rd power all over x to the 4th times 3, because we have that power to a power. Now this will give us 1 divided by 3 to the 3rd is 27 all over x to the 12th power. Now we can make this 1 over 1 times, we'll take the reciprocal of this exponent, the reciprocal of this fraction, which would be x to the 12th all over 27. 1 times x to the 12th is x to the 12th, and 1 times 27 is 27. So that is our final answer. Okay, now you may want to pause this so you could copy down E if you were just listening to it, because for me to do F, I need to get rid of all of this information for E. So take the time and pause it. Now we go to problem F. We have x to the 4th over x to the 2nd. Now we could take two approaches here. We know the order of operations state that we should simplify what's inside of the parentheses first. Now you could do that, or you could go here, since this exponent is negative, we can take this reciprocal and make this a positive exponent, because that's all that happens is when you have a negative exponent, you end up taking the reciprocal of the fraction. So I'm going to do what's inside parentheses first. So we know we will have x to the 4 minus 2, and that'll all be taken to the negative 3 power. So this would be x to the 2nd to the negative 3 power. Now we know when we have a power to a power, that'll give us x to the 2 times negative 3, which is x to the negative 6. And we know x to the negative 6 is just 1 over x to the power of 6. And that is your final answer. Now, what I'm going to do here off to the side, oh, and I went through that 6. Let me get rid of that really quick. Okay. What I'm going to do here off to the side, I'm going to show you how this problem would have been done if we would have did the reciprocal first. So taking this same problem, we would have did the reciprocal, which would have gave us x to the 2nd over x to the 4th, and that would have been taken to the 3rd power. Now, if we would have took each one of these exponents to the 3rd power, that would have given us x to the 6th over x to the 12th. Now, we'd have kept our base the same, which would have been an x, and it would have been minus 12, 6 minus 12. So this would have given us x to the negative 6, which would have finally given us 1 over x to the 6th power, which is the same as what we have here for F.